All right. So we talked yesterday about fission, mostly. The splitting of heavy atoms like uranium to release energy. But nuclear fusion is also a process that can release energy. So as you said when we were going over our homework, fusion is the fusing together, the combining of small atoms to form a larger nucleus. Yeah. Did we? I don't. Did we do the bottom?
Yeah, we did that.
All right.
Well, we didn't finish that.
Yeah, we did.
All right. So fusion is what generates the energy from the sun. The light, the heat that comes from the sun, is from the energy of fusion. Comes from the fusing of hydrogen atoms to form helium atoms. So typically, this involves different isotopes of hydrogen, deuterium, tritium, to form helium and a neutron. And nuclear fusion can release a lot of energy. And what do you notice about the sort of fuel of fusion? What is it? Just hydrogen. What does it produce?
Helium.
Just helium. And so that's one of the things that's important. We'll talk about the use of fusion as a source of energy in a minute. But fusion takes place at very high temperatures. And there's a state of matter that you may not be familiar with. So if I ask you to name a state of matter, what would you say? Solid, liquid, gas. There's also a state of matter called plasma. Plasma is generally found at very high temperatures, in the millions of degrees. And plasma is basically a superheated gas in which the electrons have been stripped off of it, and it's basically just bare nuclei.
So heat of the solid becomes liquid, heat of the liquid becomes gas, heat of the gas becomes
It
plasma.
can become plasma at extreme temperatures. And so nuclear fusion can utilize two different isotopes of hydrogen, deuterium and tritium. The names come from the atomic mass. Deuterium has two atomic mass of 2, tritium has an atomic mass of 3. And if we have these two nuclei fusing together, they could form one atom of what? Helium. And that's what happens in nuclear fusion. It exists in stars, okay, like the sun. However, it has not been able to be used to generate energy on Earth for humans because it takes place at such high temperatures. Okay.
Wait a minute.
And so there would certainly be benefits from using fusion to generate energy for people to use. And so people are working on ways of trying to do it at a manageable temperature. Because fusion would not produce dangerous waste products. Fusion can easily be started and stopped, whereas fission cannot be easily started and stopped. And it would basically we have an unlimited supply of hydrogen. Whereas for fission, there's not an unlimited supply of uranium. It has to be mined out of the ground. Unlimited supply. Now,
Another weird question. So, if you try to do fusion in a volcano or something like that?
Still not hot enough.
That's not hot
No.
enough.
So have you ever heard of people like trying to develop cold fusion? Have you ever heard of that? So that just means somebody developing some sort of process in which they can have fusion taking place at normal operating temperatures that are realistically achievable on Earth. Because that would give us basically unlimited energy for a relatively low price. But it's not really been able to be done because, again, these very high temperatures The technology doesn't exist to do that yet. So it's something that maybe someday we can achieve, cold fusion, and be able to generate limitless energy for ourselves. That would be great, but hasn't been done yet.
So it's never been done.
No. The last topic we'll talk about is nuclear weapons. Because nuclear weapons sort of set the stage for the development of nuclear power. Okay? The weapons came first. Does anyone know the name of... So this happened during World War II. Okay. There was a rush by both sides to develop a nuclear weapon, okay, based on research that was done. Do you know the name, what they called a project they did in the United States to brought in scientists from all over the world to work on this, to develop a nuclear weapon in a very short period of time? Know it?
I don't know. I know what the third bomb was though. They tried to make.
What's that?
It was called Junior.
Oh, really? I didn't know that.
I'm gonna guess a Project Blue?
No?
Project X?
No.
I don't know.
It's named after a place.
Project Hiroshima?
No.
Project
It
Arizona?
was called the Manhattan Project.
Oh my, that was a little topic.
Yes. Yes, Albert Einstein contributed some of the knowledge. He wasn't involved, as far as I know, in the Manhattan Project itself. There were other famous physicists that were. So, in the Manhattan Project, they developed some nuclear fission bombs. These two were fission bombs. They were based on different designs. The first nuclear weapon was called Little Boy. It used uranium-235 as the fuel source. It is what was called the bullet design, where basically you have a conventional explosive, just a normal explosive, that sends this bullet of uranium at the uranium fuel source through this. And then once it makes that impact, it reaches critical mass, a chain reaction starts, and it unleashes huge amounts of energy, heat. Okay? That was dropped on Hiroshima. This is what the city looked like before the bomb. This is the immediate area around it after it. So you can see, obviously, you can see the river here. Basically, all the buildings in this radius are completely destroyed. A few days later, the U.S. dropped another nuclear weapon on the city of Nagasaki. It was a plutonium-based fission bomb. It worked on a different principle. Basically, it had conventional explosives around the outside of this hollow sphere. It had plutonium in the middle, and then uranium around the outside of this ring. And these explosives were wired to all go off at once, causing an implosion and everything to collapse in the center of that sphere, creating a critical mass that could start the chain reaction of plutonium. So they're kind of different designs. Okay? Soon afterwards, Japan surrendered and the war was over.
Yeah.
Once surrendered the first time. It lost its-
So there are also fusion bombs. Okay? In a fusion bomb, we talked about using fusion to generate power. Fusion bombs don't generate, they generate huge amounts of energy, but in an uncontrolled way. Okay? So a fusion bomb is also called a thermonuclear bomb. And you might have heard it called a hydrogen bomb before, because again, that's the fuel for fusion, hydrogen. And so a fusion bomb basically fuses different isotopes of hydrogen to create what?
Helium.
Helium. That's helium, it's in the wrong spot. And also to release a tremendous amount of energy. But as we talked about, fusion requires very, very high temperatures. So how could we achieve those temperatures? Well, the fusion bomb starts with a regular fission bomb first. There's actually two nuclear bombs. The fission bomb is what is detonated first. That releases so much heat that the temperature becomes high enough for the fusion of hydrogen to take place, and then the fusion detonation happens after that. So it creates a very high temperature in order for fusion to be possible.
That's awesome. Well, not awesome, but.
Yes, so first it's a fission bomb, which then detonates the fusion bomb. And this results in a much, much more powerful explosion. Fusion bombs have not been used in a war. They exist, they've been detonated. This is the Tsar bomb. And if you look at, this is the one that was in Russia. This is a hydrogen bomb, this is the fusion bomb. Compare that, this is Hiroshima.
Oh my god.
That's how big, that's how much energy there was from this fusion bomb in comparison.
Oh,
Mount Everest.
look at the version, yes.
There are also other types of nuclear weapons that have not been used, one of which is a neutron bomb. A neutron bomb is technically called an enhanced radiation warhead. This is a weapon that was engineered to be a hydrogen bomb that gives a small explosion but releases huge amounts of radiation. Therefore, it kills living things around the blast radius, but does not, level a city like a fission bomb would, or a typical fusion bomb. The neutrons that escape from the neutron bomb collide with living tissue, they break down chromosomes and DNA, they destroy the central nervous system. It's very deadly to people and living things. So there still exist in nuclear armed countries thousands and thousands of nuclear weapons. Over time, they've been reduced somewhat. People recognize the danger of nuclear weapons, and like you said, the world community generally dissuades countries by sanctions from developing new nuclear weapons. But again, there are sometimes countries that decide to pursue developing nuclear weapons anyway. Sometimes they face sanctions from other countries. That's what happened in Iran. Iran continued with their nuclear program, and there were sanctions against them about importing certain goods or banking and so forth. Then eventually they made an agreement saying they were going to stop developing nuclear weapons. The sanctions were lifted. There's monitoring that goes on. In a country like North Korea, where there's not a lot of outside presence in the country of North Korea, then there's no regulation of that. And they've been testing nuclear weapons over the last several years. More recently, they started testing missiles. Because nowadays, all right, so quiz Tuesday, not tomorrow.
And then there's